Okay, sorry about all these cuts. I'm making mistakes and hoping not to go all the way back. Okay, so we've said that this is basically the possibility tree. And so that means that we have all these different possibilities. So we can have a migration and then a coalescence, or we can have a migration and a migration and a migration and a coalescence, or we can have 5 migrations and then a coalescence, and so forth. And so in each one of these is one possible way to coalescence. So we can just work out the probability of each of them and the length of time that each of them takes up. Then we'll have a total expected amount of coalescence, right? Because it's going to be the probability that this is the path times the expected length of that path times the probability that this is the path times the expected length of that path, and so forth. And this will overall give us the expected length. Okay, so we want to figure out the probabilities and the lengths of each of these things. So let's start with the simplest one, MC. Okay, so here's the probability and here's the length. And actually let's do the length first because it's a little bit simpler. Okay, so the length of this is just so first we're in different subdivisions, so we have to wait for a migration. The rate of migration is 2m, so the expected waiting time is 1 over 2m. Okay, and so then next we have to wait, so it migrates over, one of them migrates over, and now the next thing we have to do is wait for an event. Now, it turns out that event is a coalescence, but if we're only talking about the total length of this tree, we just have to ask what is the waiting time. And so the waiting time is equal to 1 divided by the sum of the rates. And so that is our total length. It's this length plus that length. Okay, and so, sorry, that should have been P, not C. And so what's the probability of this? Okay, well the probability that there's eventually a migration is 1. You might have to wait a long time, but eventually a migration will occur. So the probability of this first event is just 1. And then the question is, what's the probability that this second event is a coalescence instead of a migration? And we've worked that out. That is the probability of coalescence divided by the probability of coalescence plus the probability or the rate of migration. Okay, so this is the contribution to the overall length of the tree, the length of the, this is to the overall expected length. This is the contribution of the shortest possible history, where we have one migration and then a coalescence. And so that's just this value, the expected length, times the probability that is the history. Okay, so now we can do the next simplest one, a migration, a migration, a migration, and then a coalescence. Okay, so the length of that is the waiting time until a migration, and then the waiting time, so now we're here. Now the waiting time until one event or the other. Okay, and then we'll get to the probability that the next one is a migration. But if the next one is a migration, then we have another waiting time until a migration. And then we have a waiting time until an event. I'm sorry, I made a mistake here. This should be 2 over n. This should be 2 over n. Same here. Okay, so that's the length, and now the probability of this. Well, the probability that we take this path is, okay, so first, chance we get to a migration, so that's 1, times the chance we got to a migration instead of a coalescence. So here, that probability is 2m divided by 2m plus 2 over n. Okay, so that's the probability that we went to this fork. And now we have to wait again for another migration. So that's just a probability of 1. Let's get rid of these probabilities of 1. We don't need them. So that's now the chance. Okay, so we have to wait for this, but the probability we get here is 1. And now there's the fork in the tree. And so what's the probability that when we get this event that it's a coalescence? And that probability is equal to the probability of coalescence divided by this. Okay, so if we look at it, this is the probability of migration given there's an event, and this is the probability of coalescence given that there's an event, right? Because the first fork in the road, we had to have a coalescent, we had to have a migration. The second fork in the road, we had to have a coalescent. Okay, let's do one more. Space down here. Okay, so we have 5 migrations in a row and then a coalescent. Migration, 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 coalescent. Okay, so now the total length of this is going to be the waiting time to the first migration, and then once they're in the same subdivision, the waiting time to an event, and then waiting time to the next migration, and then the waiting time to event. Okay, so that gets us to here, and then the waiting time to the next migration, and then the waiting time to an event. So I think we're starting to see that we can summarize this, right? So this was this value, which is equal to 1 over 2m plus 1 over 2m plus 2n. So it's that value, here it's that value times 1, because it's a migration plus a coalescence. Here it's this value times, because it's a migration plus an event, migration plus an event. Here it's a migration plus an event, a migration plus an event. Here it's a migration plus an event, plus a migration plus an event, plus a migration plus an event. So the length of these things is actually just equal to the number of the path. Let's call this path number 1, path number 2, path number 3. So it's equal to the number of the path. So 1 times this value. Here, it's equal to 2 plus 2 times this value. Here, it's 3 times this value, and so forth. Okay, so that was the length of this path, the expected length of this path. What's the probability of this path? Well, now we have the first fork in the road. We have to have the probability that the first one has to be a migration, given that there's an event. And then the second one has to be the probability that there's a migration, given that there's an event. And then the third one now has to be a coalescence, given that there's an event. So we can also start to rewrite this. Okay, so this one is the probability that there's a coalescent, given that there's an event, right? Because this was the case where the first event, where there was a fork, was a coalescence. This one was the first fork in the road had to be a migration, and the second one had to be an event. And then this last one is 2 of these in a row, and then 1 of these. Okay, so we start to be able to write down a general formula for this stuff. So, because we can now write this down as a summation. And let's do it from I equals, it's always easier to do it with I equals 0. Okay, so then this would be the 0th term. So then that would be I plus 1. Because if I is 0, then this 1 is I plus 0. I'm sorry, is I plus 1. times this value, and so that value is equal to 1 over the, I guess I'll just write it all out. Okay, so it's that value times, and we can summarize this, right? This is the probability of mutation given that it's an event, which is probability that it's migration given that there's an event. And that gets raised to the ith power. For our first term, it gets raised to the 0, because it's not there. For the second term, it gets raised to the 1 and to the 2. So when I is 0, it gets raised to the 0. When I is 1, it gets raised to the 1, and so forth. Okay, so we've dealt with this. We've dealt with the probability of m given e. And now we just need this last one, the probability of c given e. And the probability of coalescence, given that there's an event, is just this. Okay, so here's the whole thing, or if we want to, we could also simplify this. If we use big M is equal to 2m, and we use big C is equal to 2 over n, then we can rewrite this whole thing as I plus 1, 1 over m plus 1 over m plus c. So these are all going to be big letters. Sorry if it's not clear. Times that, times m over c plus, m plus c, times c over m plus c. And then this gets raised to the I. Okay, so we can actually, so this is getting a little bit deep into the math. I just want to say that I hope that we can see that this is possible to write down. It might take you a little bit longer than it took me because I've done it a bunch of times and had to stop the video a bunch of times and try it again. But that this is possible, that basically this somewhat more complicated situation, we can work out and actually write it down. So now we'll just take a couple more steps and see if we can get the math even simpler. Okay, so when you're looking at a summation like this, it's useful to try to take out the terms that are constant, the terms that are not dependent on I, right? Because, so here, this I plus 1, that changes with each term, but then it gets multiplied by this thing that's always there, and this thing that's always there. See, these two terms don't depend on I. And so we can take those out and make our lives a little easier. So we're going to take this 1 over m plus 1 over m plus c out, and we're going to take this c over m plus c out. And now we've got a simpler summation, I equals 0 to infinity, I plus 1, m over m plus c to the I. Okay? And so we can actually, so now the other thing we can do is we can take this term and we can split it. So I'm going to take this 1 out here and bring it into its own term. So this is 1 times m divided by m plus c to the I. We're going to erase this tree because it's in our way. Okay, so now we have this being multiplied by both of these summations. And now we see if I can do this. Okay, so now we can recognize that this can be written. So let's do a substitution where we're going to make r equal to c over m plus c. Okay, so now we said, so then that means, oh, I'm sorry, let's do it with just r equals m over m plus c. Okay, so then if that's the case, then we can simplify this down to summation of I, r to the I. Sorry for that, we're going to go back and do the other thing. I wish I had an undo button here. Okay, so this was m over m plus c to the I. So actually, let's make r equal to c. If that's the case, then 1 minus r is equal to m divided by m plus c. So then now we can write this as 1 minus r to the I. Okay, so we can then recall that this summation is equal to 1 over r. Sorry, 1 over little r. And we see that this term looks quite similar to that. It's just missing an r, but actually this thing is an r. Okay, so let's redistribute this r. We're going to put this r here in this term. And we're also going to put it in this other thing that's being multiplied by here. Okay, so now this thing looks just like that. And we can rewrite this term as 1 over r. And then what about this term? Well, this term can be written as 1 minus r. And if we go back, we learned that we did it with p. I'm sorry, I made a mistake here. There should be an I there. But here there should not be an I. So 1 minus p to the I, and we learned that this was equal to 1 over p. Okay, so that means that this summation here is equal to, notice just it's the same with p versus r. So this actually is equal to, so the r that was there times 1 over r, or actually just equal to 1. And so we're starting to get somewhere here, okay, right? So we've got 1 over m plus 1 over c. I'm going to just migrate this out over here. So we have 1 over m plus 1 over m plus c times 1 over r. So this is r, so that is equal to the inverse of that. So m plus c over c plus 1. So I think I'll leave that there for now. I think that's plenty in this video, and I'll think about what else we should do with these links.